Well, my name's Andy Walton. I work at Altera in our System Solutions Engineering Group in the UK. We work with some of our larger customers developing designs on some of our larger parts. The particular group I work in is the networking group. So Mike contacted us and asked would we put some challenges together. He seemed to think FPGA particular challenges may be of interest. So I have tried to focus more on those. However, we have many of the same challenges that everyone else does for verification, resourcing, multi-site development, etc. In the group I work in, most of the designs are what we would consider traditional. For example, in other groups we will generate RTL from MATLAB designs and things, but the designs I've been associated with have been focusing on traditional RTL design, where we use IP blocks from within Altera and from third parties. Often our customers will provide some code when we're co-developing with them. Reuse tends to be often not direct. It's either highly parameterized IPs or reused by editor. I think this is my experience from previous places, is that FPGAs seem to modify the design more than an SoC or ASIC team would, presumably on a risk basis. Well, the first challenge that I considered was the flexibility. The unique selling point of FPGA is that you can change them, and people do. So we have this model which is a cross between hardware and software. So we want to be able to modify the design, be flexible to market changes, and perhaps do multiple releases, which isn't necessarily possible for an SoC. So again, my experience at Altera is that changes come in, we'll speak to our customers, and changes will come in later than you would expect for a silicon-based design. So we need something that allows us to change. The problem we've been having is that we just don't have the same time at the start of a project to build up complicated environments. And the other thing is that the release from the RTL complete to people using it on hardware is a lower bar than for an ASIC. And this is because you can use it on the FPGA, so people are prepared to do some work, if you like, post sign-off. However, that doesn't mean that the designs, when they're deployed, have to be unverified. One of my customers said that it takes them a year to get their product qualified, so there is no, once the design is complete, it needs to be correct. The other difference between FPGAs and software, of course, is it still needs to work. You still need to close timing, place and route. You can't have a completely software-like model. So the waterfall style approach to verification doesn't necessarily work. We can't just do all of our verification environment, what one of my previous colleagues at Mentor called manager worry time, where you're building the environment and not doing testing, because as things keep changing, that time gets longer and longer. So what we need really is a more agile approach to this, and this is obviously what we're looking at internally, but from an industry point of view, it would be good if we could try and look at these technologies that are proposed and wrap them up in such a way they can be more efficiently deployed. The second challenge that we considered was the system level of UVM. We wanted to put together system level environments where we have IP from multiple places. Unfortunately, not all of the block level designs are UVM based. So it then becomes a very massive task to backfill things like scoreboards and reference models in UVM to existing IP, to the point it makes it not so attractive. Without this, it becomes a barrier to adopting UVM, because whilst you may be able to generate the stimulus at some interfaces, you can't necessarily collect the coverage and do the checking that you would like in a self-checking test bench. So the problem we need to solve is that if the migration from using some legacy and some UVM components to a UVM world. And one last thing on this point was we have had sites around the world provide us IP with UVM test benches, and we found they don't always integrate as well as some of the UVM proponents might suggest they would. Often, but not always, passive components where it's buried in the design, the self-checking and the coverage may work, but sometimes the scoreboards are configured by the unit level tests, which then isn't available at the top level tests. And by and large, active tests, unless there's been quite a lot of effort up front, haven't been as reusable as we like. And the third challenge, which is kind of the obvious one for an FPGA, is people just want to run on the hardware. And it's not an unreasonable thing to do. It is part of the value of the FPGA. And you never ask a software engineer not to run on a CPU. So, yeah, but there are challenges with that. The hardware isn't always available, but the biggest problem is very, very difficult to debug complicated problems. The FPGA designs now are huge, or at least the ones who are associated with, and you can't just second guess and put the odd signal tap probe on to find all the problems. And even when you find the problem, it's not always easy to take that back into the simulator world to work on the problem. And lastly, if people are testing on the hardware, you don't have the same coverage metrics, the kind of things Tim was talking about on the emulator. You need to be able to look on the FPGA and say, have we really tested these interfaces? So again, what we would like to see here is some unified methodology so that we can seamlessly transition between real hardware and a simulator environment. And I added a fourth one because this hasn't actually hit us yet, but the day after I wrote these slides, this came up on a project, so it was fortuitous, is that FPGAs allow you to reload sections. This is more like software overlays, and this isn't something you don't find on a piece of actual silicon, an ASIC or an SoC. So some way of simulating these will become more important as time goes forward. This is similar but not the same to the power aware, because you're rather than switching things on and off, you're actually switching different designs in. And lastly, we did have a number of other items we discussed, which we decided came lower than the ones I've listed. Many of these have been covered in previous presentations, so I didn't see any point in repeating them. And that's my presentation finished.